Hello everybody. We have an integral calculus question today, and this question is slightly trickier than it appears to be. Okay? We need to integrate this function log x all over 1 plus log x squared whole square with respect to x. Okay? Now this function doesn't look really good to be integrated by known methods directly. So let's try and simplify the integrand. So we have 1 plus log x in the denominator and just log x in the numerator. So let's try and make the numerator and the denominator similar. Okay, let's try and make them look similar. So we add log x so that this part and this part look similar. And since we've added 1, we're going to subtract 1 in the numerator. Okay? All right. Now let's split this modified integrand into two parts. We're going to write 1 plus log x all over 1 plus log x whole squared, which will give us 1 over 1 plus log x and minus 1 over 1 plus log x whole squared. Something like this. Now using the linearity property, we can rewrite this as 1 over 1 plus log x dx minus 1 over 1 plus log x squared dx. Now we'll tackle this integral if we have to later on. Now let's just focus on this integral. Now I'm going to integrate this integral using by parts. Okay, so I'm going to put this integral as it is. So continuing all the way over here, we're going to have minus 1 over 1 plus log x squared dx plus 1 times 1 plus log x raised to the power minus 1 dx. All right. Now to use integration by parts for this, we're going to take 1 plus log x raised to the power minus 1 as the first function and the constant function 1 as the second function. Okay. So the first function is 1 plus log x raised to the power minus 1, and the second function is, this is just a rough notation, okay, is the constant function 1. And what we need to do, we need to integrate the second function without the constant of integration for convenience, okay. So integration of the second function is simply x without the constant of integration, and we need to find the derivative of first function, which means we have the derivative of first function as minus 1 plus log x raised to the power minus 2 times 1 by x. All right. Now we're going to have this part as it is. We're going to tackle it later if we have to. Plus, now we're going to use integration by parts for this integral. So the first function, which is 1 plus log x raised to the power minus 1, which basically gives 1 over 1 plus log x, all right? And the integral of the second function, which is simply x. So 1 by 1 plus log x multiplied by x gives something which looks like this. Now, we have the negative of the formula for integration by parts, the integral of the derivative of first function, which is this thing right here. We can write it as minus 1 by x times 1 plus log x squared. All right. Now this minus and this minus makes this part a plus. So we have 1 by x, 1 plus log x squared times the integral of the second function, which is x dx. Okay? Now that's all we need to do. Okay, let's cancel out this x with this x so that we have x over 1 plus log x plus whatever it is here, 1 over 1 plus log x squared dx minus whatever that is here, which is 1 by 1 plus log x squared dx. Now, here's the tricky part. These two expressions, they look the same, but they aren't necessarily the same, because this represents an antiderivative of this function and this represents an antiderivative of this function. Okay, and the two antiderivatives of the same function may not be same. For example, let's say the antiderivative of 2x can be x squared, one of them, and the other one can be x squared plus 1. Clearly these two functions are not the same. So we cannot cancel these two expressions out and say that the required answer is log x plus 0. No. These two may not cancel out to give the result 0. Okay? Now let's say now that's the basic concept. Okay, that's the basic concept. But what we know is that if this is an antiderivative of 1 plus log x squared, 1 over 1 plus log x whole square, and this is also an antiderivative of 1 plus log x whole squared. Okay, 1 over 1 plus log x whole squared. So the two antiderivatives of the same function, okay, if a1 is an antiderivative of the same function fx represented by fx, and a2 is also an antiderivative of the same function fx, then the difference between them is some constant, let's say c. Okay, let's say c. So these two will cancel out, but what we're going to get is some constant c out of them. Okay, that c can be 0, cannot be 0, may be 0 or may not be 0 is what I meant to say. Yeah, so these two antiderivatives will cancel out to give a constant term. Okay, will cancel out to give a constant term. Let's say c, and this is our required answer. The other way you can think about it is that if we say if we assume this part to be some function phi x plus c1, okay, phi x plus c1, then where this part of the function, this part of the antiderivative is free of constant terms, free of constants, then this antiderivative will be something like phi x plus c2, okay, phi x plus c2, and we do not know if c1 and c2 are equal. If they're equal, c will be 0. We'll get the result to be 0. And we get phi x over here because it's free of constant terms, free of constant terms. So if we do not get phi x over here, the difference between the two antiderivatives might not be a constant, which is not possible, okay, which is not possible. So if we assume this to be something like this must be phi x plus some other constant, possibly some other constant. So the difference between them will result in the cancellation of the part of the function which do not have constant terms, okay, and the result will be c1 minus c2, which is a constant that we denote by c, okay. You can understand it this way as well. So basically, here's the trick: do not cancel them out to get 0, okay. The cancelling of indefinite integrals is not really allowed. If they're definite integrals, you can differentiate them, cancel them out. But in the case of indefinite integration, you're not supposed to cancel these out. This is the main trick right here, which I've explained just now. All right? So, if you've understood this, then you can simply write it as x by 1 plus log x plus c. Okay? All right. That's all for today. Thank you very much.